Hi folks, welcome to the Break Key. My name's Henry and today we're going to do some brain rebooting. Why? Because I got caught with human malware. Yes, the disease that shall not be named kind of took my vacation and turned it sideways. But you know what? It thankfully was not that terribly bad for me. And I pray that should any of you out there be suffering from that either now in the future, what have you, whatever it is, I pray that you get through it well, and I pray that you get through it without any problems whatsoever. So today we're going to boot the color computer. Wait, what? Yes, boot the color computer. Because in order for the color computer to actually boot, to actually come up, there's a few things that have to happen. And I've got this crazy notion that I want to kind of like maybe write my own ROM for it, and as far as like a operating system, and base it on Forth, because I'm either a masochist or really love reverse Polish notation. I think it's both. At any rate, so the first thing to do if we're going to do this from scratch and start it from scratch is to get some kind of development environment put together. And yeah, I could do that on bare metal, but that means that I have to have some kind of solution to have an easily reprogrammable EEPROM plugged into the main board. And the problem with that is that I don't have real-time debugging available in the way that I could with an emulated solution, such as, for instance, MAME. And MAME's debugger is absolutely amazing. So anybody out there, if you're doing any type of development for the color computer or any other type of 8-bit system or any other type of system that needs a debugger, for crying out loud, that's emulated by MAME, the MAME debugger is awesome. Go ahead and use it. I recommend that. But getting right back to it. To bring up the color computer, it's actually kind of something that's not like really, I'm not going to say it's not easy to do, but it's something that's a little bit convoluted to do in the fact that you might think all you do is you throw some code at it and it's going to run. Well, it's not quite that simple. Every single, let me do this. Let me pull up the technical manual. All right, I'm going to use the Color Computer 1, the Color Computer 1 technical manual for this, because it's pretty much the same thing, at least for the 1 and the 2. I'm not sure what the bring up looks like for the, or I'm not sure what the bring up looks like for the 3, but at least for the 1 and the 2, it's relatively simple-ish. But there's more to it than just, throwing some code at it. So let's start with this page right here. And what we see are vectors. LSB and MSB, vectors. What does that mean? Well, CoCo Towns talked about interrupt vectors, and I'm sure that AC's 8-bit has as well. All these other places have talked about interrupt vectors, how to use either the interrupt vectors or to use or to code in such a way that you don't have to use the vectors at all. But the point is that there is, if we're going to bring up the machine from scratch, there is one vector that absolutely, positively must be defined and must exist in whatever our firmware is, and that is the reset vector. That reset vector is the first place that the processor is going to look to find a place to go. And all that reset vector is, and it's the same for any of these other vectors, but all that reset vector is an address in memory where it's going to find the code. All right, so should be simple, right? Let's try this. Let's try this and see what winds up happening when we set up the reset vector. Now, beautifully, we have a mirror happening here. It's either quad F, FFFE and FFFF, or BFFE and BFFF. Okay, it's one of those two, and that makes it easy so that we can go ahead and so that Color Basic, for instance, in its 8K ROM at the top of that 8K, it's a it's able to have that vector right there and available rather than trying to write something or have something hardwired in. So we'll start by assuming we're going to start at A1000, which is where the color basic ROM, not the extended color basic, but color basic ROM begins, is at A1000. Org A1000, great. The next thing we want to do is, once we're there, well, we need to be able to do something. This is going to be the basic, most fundamental thing without doing anything else. So let's just go ahead and just have it jump to itself. Okay, branch always end, why not? And then the next thing we need to do is put together our reset vector. So let's go ahead and set the org, okay, to BFFE, which is where we're going to see that vector mirrored. And that should do it. That should do it. All right, so we've saved this. Okay, assembling beyond addressable memory. What is that? And that said it was on line 2. Oh, because I've got one too many zeros in here. Ain't that a peach? Okay, now save that, get that out of the way, do that again. All right, now it assembles. Got the 01.ROM, and it's 8,192 bytes long, which is perfect. And now the next trick is going to be seeing if we can't get that brought up in MAME. Now, MAME does not like it in the slightest when you use a ROM that it doesn't know anything about. So there's some hoops that we're going to have to jump through to get it to do what we want it to do. So I'm going to go over to my ROMs directory. Okay. And let's see. I've got the original stuff for the CoCo. I've got the CoCo modified. I'm going to get rid of that one. And I am going to grab that. I'm going to grab there and bring it over here. So /bas10.rom. Okay, and then okay. So all right, got that in there. Now I've got that in the place that MAME expects it to be. I've got it under a name that MAME expects it to be. So MAME should do some complaining that I know it's going to do. All right, it should do some. Okay. MAME. All right, so I'm going to try CoCo, and I'm going to try. Let's see. Let's do this. Let's list the slots real quick. All right, and for the extension, because I'm going to need to make that go away. We're going to use. Yes, the max. Okay, I'll use the max. Name CoCo minus window minus no mouse. Next max minus BIOS B10. And I should get a complaint about BAS10 being. Okay, good. That's exactly what I want to see. Boom. Bob's your uncle. It looks like we're doing fine. So let's do that under the debug. And I'm going to turn off sound. Okay. Looky right there what we've got. All right, so we have our ROM in place. It's there. It's what we want it to be. Beautiful. This is perfect. Okay. And hang on. Okay, so Control Q will do that. All right, so the ROM's in place. Things are looking good. All right, so let's see. What's the next thing that we're going to need to look at in order to bring that up? Be there. All right, so what's next? So now we need to actually set up the machine so that it's sane. And in the case of making sure that it's sane, that it can actually print things and do what needs to be done, there are initial peripherals that need to be set up. If any of you have ever done any like assembly work on any type of Atmel or other type of microcontroller, then you know what I'm talking about. It's not just throw code at it and it goes. It's like you have to set up certain things in order to make it work. We need to set up the two PIAs and we need to set up the SAM. So we come back to our good friend, let me do this. I will leave this always on top. Okay, we come back to our good friend, the technical reference manual. So what we want to look at here is what's going on. First of all, let's set up the PIAs. That's going to be relatively easy. In case I misspoke myself a bit ago, because I'm looking at a few things while I'm doing this, what we're going to do is we're going to zero the control registers of the PIAs. So these control registers, which are FF21 and FF23, if we clear those, if we zero those out, now we have the ability to set up the directions of FF20 and FF22, which we need to do before we can get anything else accomplished. All right, so the first thing we're going to do, clear out PIA control registers. Okay, so that should do it. I hope that does it. I think that'll do it. I've actually never used a direct page before. Wish me luck. Okay, and so we look at FF20, and that's going to be, it looks like it's going to be FE because everything's an output except for this, which is an input. Okay. And then for the second PIA, FF22, it looks like that's going to be input, output, input, output, 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 which is a 0, and we've got that is 5. So it looks like that's going to be a 0, 5. Oh, right. Okay. Yeah, so that's going, no, it's not going to be that. I had my sense backwards. So that's going to be an F, and that's going to be, let's see, 8A. So that's going to be an FA. All right, now having set the directions, we need to set up what the control registers are doing. So okay, and at that point, everything should be sane with the PIA. Let's assemble that and make sure that nothing, that it actually is sane. All right. Let's see if MAME, let's see what MAME, how MAME feels about it. Oh, of course MAME doesn't like it. Because I didn't zip it up. It's still not working. Okay. All right, that's doing what it's supposed to be doing. Let's go over here and make sure that it actually assembled. Did I save that? Huh, that might have been the problem. I didn't save it. Okay. Let's go ahead and zip that up. Deflated 99%. Okay, that's a good sign. All right. So it went all the way to the end there. Okay, so let's set this up. Everything appears to be good. Let's look at the debug. Okay, everything, okay. So everything appears to be good. And let me do this. Okay, and we'll grab you. Okay. Debug. BP set. 0, 0. Okay, breakpoint 1 set. And let's go ahead and do a reset. I think it's an F3. Something went awry. Oh. Oh. All right, note to self, always look at the listing when it comes out to make sure that what we're doing is sane. All right, so what I'm going to do is I'm going to back up to this part where I was looking at the, well, let's see, we're going to control Q this. Back up to over here, and then come back to where I was looking at the listing. Okay, so I assembled it. We're gonna look at this again, and we're going to look at the listing. Okay, now B600FF, da 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 da. Okay, so I'm just completely doing that wrong. Okay, no problem. I'm completely doing that wrong because what's happening here is it's not referencing the direct page. I'm not sure how to get it to reference the direct page, so I'm going to go ahead and look at that real quick. Oh, okay. That makes sense. Okay, cool. So what I can do there, let's make this, let's edit this out. And there's probably an easier way to do this, other than putting it in front of every single one. Da, 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 da. To a negative number to undefined and disable auto use, and this is the default. Oh, okay. All right, so let's try. Well, I'll worry about that later. I'll worry about that later. I'll just go ahead and get this. I'm going to go ahead and get this done here now. Oh, so work it out. All right. But that should give me direct addressing. So if I save that and I'm come over to that terminal. Yep, that terminal. Yep. Nope, that terminal. I need, where's the other terminal? Oh, it's that one. Okay. Oops. Yep. Okay, that looks a lot better. That looks a whole crap ton better. Okay, and that should set all the registers. Now, let me go through, because it may still not stop. I'm not entirely sure why it's not stopping. But, all right. So we'll control Q and move on. So what's the next thing we need to do? All right. So I'm going to assume that the PIAs are set up the way that they're supposed to be set up. The next thing that we need to do is make sure that we set up the SAM. And I'm not even going to worry about trying to figure out how much memory is there right now. I'm going to go ahead and say, all right, we're dealing with the split setup like we normally have. And that should be relatively, simple to do. And so in doing that, we're looking at our SAM registers. What are we going to store where? All right. So what we're going to do is just simply write in these values right here. We're just gonna bang those in there and just set them up, just brute force, not even worrying about like making anything kind. Now the main default is for a 64K machine, so we're going to set our memory size to 64K. So next, those are the vectors. We've already looked at that. We know what's going on there. The next thing we need to do is get the VDG actually set up, which is going to be here in FF22. We've already set the VDG control. We have not set the VDG control output, I should say. So what we can do is we can go back where we had that set on FF22 and, oh no, that's an output. Never mind. Okay. Set PIA control registers for operation. Okay, load A3C. Let's see on 21 and 23. So what we can do is, okay, no. So I thought I set it up there, but I obviously, let's see, up there, where's there? There we go. Okay. I thought I set it up there, but I didn't. Uh, it's not that I missed setting it up. It's that that wasn't part of the setup. Okay, so now. So that's there. Now, if this has been handled correctly, what I should see at this point is the screen should be green be green or something like that. We'll see what MAME thinks. All right, so I'll Control S that. Let's Alt Tab back over to our compiling area. Yes, we're going to go ahead and. Oh, yeah. What? Oh, I put the comma in the wrong place. Okay, all right. So, boom. LEAX 1 comma X. That's what I needed to do. So let's F5 that bad boy and see what happens. All right, you're still orange. Oh, you know what I can do is I can try it in XROR. All right, so it's not doing anything. Well, there is one way to find out what I can expect, and probably something I should have done at first. And that's to look at a working unit and see what's going on with it. But do I have the question? I wonder, do I have any errors? The first one looked like it was trying to work, and at the very least, I can go ahead and put a little more code here and see if it does because it's at least trying to boot. I know that much, but MAME doesn't want to let me debug what's going on. What's going on over here? Well, yep, that stuff. Sorry, not used to pointing at things that are in the opposite position, but over there, the code, yeah, that's what I'm talking about. Okay, so where am I at? Okay, so we're looking at this 180. I just put that in there to see what it's going to do. It skipped it completely. All I needed to do was look at the last line of the code to tell me what the heck I did wrong. All right. So I'm going to go ahead and say, can you guys see why I've been going through this little problem of not knowing what's wrong with it, as in it won't run, it doesn't seem to be running the top stuff. Can anybody look at this stuff over here and tell me what that is? Because I sure couldn't for a while. And you know what? You may have been screaming at me and slamming your fingers in the comments because, hey, Henry, that's your address right there. That's where it's gonna go. That's the reset vector. And guess what? The reset vector starts here. So why don't I change the actual reset vector to, oh, I don't know, start? And we'll use that name. And then I'll come up here to the top of where everything is and call this start. Okay. And I'll fix the problem that it's not using tabulators later. Okay. And now I'll get rid of this. Oh, because that's what clued me into the fact that I was being stupid. All right. These kinds of mistakes happen. Aren't they fun? So let's try that again. We're going to assemble U. We're going to look at this and make sure it's sane. It is. We're going to copy that over. Then we're going to zip it up. Then we're going to MAME it out, MAME on it. Okay. And now it's still there. Let's make sure that what we're looking at here, let's get a, is what we want to look at. Give me I want a memory window, and I want to see what, okay. A043. So that's still not doing what I want it to do. Let me guess. I probably forgot to actually save this. We've done that before. Nope, not that one. I need that. That. Okay, unknown instructions start. Lovely. Now, that's not... Aha! There we go. That should fix it. All right. And that's sane. Let's check this. Note to self, Henry. Check the listing for... The listing's a good way to look for bugs and errors, because this would, if you looked there, you would have seen that BFFE did not, in fact, contain 8,000. That BFFE contained, oh, 8,040. Something like that. And then you can do, oh, goodness gracious. Wow. I can be dense sometimes. All right, so now we can copy that back over. We can, no, I did not want to name that out yet. So Control Q U, and we want to, we'd already copied it over. I want to zip it up, and let me see if I can find, so I'll go ahead and move this over here. Let me go ahead and Control W this out of the way, and this way. All right. Oh, ha, ha, ha! Look at that, the debug thing's right there. So if I hit, let's try the F5 and see what it does and see if it breaks. Okay, it's sitting right here. should look at 0400. Okay, that contains a whole bunch of FFs. And let's look at, let's go ahead and F5 this. Let me look at this real quick. All right. Okay. All right, because FF is, got it. That's why it's orange. Again, all right. So it booted. Okay. Beautiful. So let me Control Q that, and we'll run back over to here real quick. Now, so I've got that. I set it, it's set up appropriately, everything's working, and all my stupidity has been dealt with. Well, maybe not all of it, but at least this little bit of it. It's not that I don't understand assembly language. It's that it's been so long since I've actually played with 6809 assembly language that I'm not sure what it can and cannot do. You know what I didn't do? I didn't set up FF100 through FF03, and I need to do that. I completely missed that PIA. And it looks like it's going to be a 34 over here as well. Yep, that's going to be a 34. And 21. All right, cool. So that'll work for that. So those are set up. Good thing I saw that. That was enough. Yeah. Oh, well. That's set up. That's set up. So, all right. So the next thing I want to do. Okay, let's check and make sure that that makes sense. Okay, yep, it's loading that. Okay, loading that. All right, branching of less than, and that should do it. Okay, good. Let's redo our that thing. Do that thing. Let's just hit an F5 and see what F5 and see what happens. Nothing. There we go. I did another silly. Let's go ahead and check this because it's supposed to be load A, pound $1.20. Thank you. All right. Then do that. And then do this. And then let's run through A051. And let's F5 up to that point, and let's see what we've got going on. All right, so A should contain 20. Does A contain 20? A contains 20. Good. And we'll hit that. Yep. Okay. So let's F5 that. And there we go. An absolutely wonderfully, beautifully clear screen. So the next step is going to be oops. That wasn't what I wanted to do. I wanted to do the main thing. There you are. Okay, let's F5 this just to make sure that... Oh, that didn't work. And you know what? I know exactly why that didn't work. At least I think I know exactly why that didn't work. Because I think I've got a wrong constant in here. I think that actually is supposed to be 40, not 20. So save that. I'll tab over. F5 that. Almost. Almost. But you know what? I'm going to call that a win. And you know why I'm going to call that a win? I'm going to call that a win because it did what I wanted it to do. I did not do the calculation for for the periods and whatnot. I was using an ASCII value and I was using a trick and I didn't look at everything there. But the words got there and I got what I wanted. I actually got what I was looking for out of it. And that is right up there. Right up there. That one. Yeah. Hello world. It did it. So yeah, I got Hello World mostly working. I mean, it's not as epic as Usagi Electric's Hello World. I'll grant you that. And semi graphics characters are kind of unpronounceable. But you know what? Hey, there's the first thing. I have successfully booted a CoCo 1 with my own ROM. It don't do nothing yet, but it's successfully booted. And that's where the fun is here at the Break Key. Thanks so much for joining me today. It was a long, drawn-out affair, I know, but what hasn't been so far. And there's more to come. Oh, God, here we go. But it should be fun to be around, especially, you can laugh at my mistakes, you know? And what's a more fun thing to do than laugh at my mistakes? Like, share, subscribe, just let people know what's going on here. There's fun to be had because hey, you're watching somebody learn as he goes along, and hopefully you guys are enjoying learning this with me here at the Break Key.